Hi, today we'll be looking at file I/O in Python. File I/O is kind of the way that we can manipulate, create, delete, and do stuff to files in most of our exams, and actually any project that you build in Python. The thing is, you can kind of do file I/O with any file, but for the purposes of today, we will be dealing strictly with text files. And some people might want me to cover CSV files, but you can just kind of ignore CSV files as a whole. You can treat them as text files and do all of the stuff that I'm about to show you to them. We don't need to give them any special treatment. And I would argue that it's easier to do it this way. So hang on tight. But if you do want a tutorial on CSV, then let me know. I'll do something about it. So without further ado, let's get right into it. So about file I/O. Firstly, I need to make this clear. There are 4 things that we can kind of do with a file. So let me just write this down. 4 things we can do to a file. Firstly, we can do writing, which is a W. Then we can do reading, which is an R. After that, we can do appending, which is an A. And lastly, we can do X, which is creation. I'm probably not going to go over X because you can create files by writing. But it is good to know that you have an option to just create a file on its own. So, well, the difference between writing and appending is that if you write to a file, you're writing over what already exists. But if you append to a file, it's safer because it just adds information to the end of the file. You don't risk losing what's already on the file if you have to read it. So, yeah, that's kind of the main thing we have to look at here. And then after that, 2 types of files. Wow, my writing is not good today. Firstly, we have T, which is a text file, which is kind of all of the files you're going to experience in your exams, and I guess more or less almost all the files you will ever experience if you're dealing with Python. But you do have this thing called a binary file. A binary file can be, for example, an image. It's a bit more complicated, but it's kind of rarer for you to see this kind of thing, so I don't think we need to go too deep into it. So let's get right into it. Firstly, section 1. Let's look at how we can kind of open files. So if you'd like to open a file, you have to use this thing called open. It's a function. Open kind of just opens a file and it returns the value so you can store it inside of a variable. So how can we use this? Let's say we have a file that we want to open called hello or hello.txt. In this case, you could put open hello.txt bracket the mode that you want to open it in. And how do we kind of dictate what mode it is? Well, from the above WRAX. So if you want to open it in writing mode, then you would put W. And from there, you can put file is equal to open hello.txt bracket W. What this does is that it kind of opens the file and stores it inside of the variable called file, so that whenever you manipulate the variable called file, the changes can be reflected onto file itself. So yeah, let's kind of see how this goes if we run this. Well, if we run this, nothing actually happens, and that's because when you run code that creates a file, it will just do its thing behind the scenes. You don't really get some sort of indicator that the file has been created or destroyed or whatever. So if you want to bug test your own code, I do recommend writing your own print statements. But yeah, just know that your computer will not really help you with this. And do keep in mind, you might be wondering, wait, how do we know whether this file exists or not? You just said open a file, but I don't think that file actually exists. Well, if you open a file that doesn't exist, you are creating it. So if hello.txt had never existed so far on my computer, then it would have created hello.txt and then given it like no values inside, like blank values. So yeah, then if we do that, again, we have to close the file at the end. So here's where it gets very interesting. When you open a file, you need to close it no matter what, because it's just good practice and it saves a bunch of resources. But there is a method that does not require you to kind of use both open and close. because you do write open, you must write close if you want your marks for opening and closing. If you miss one, I believe it's -1, but that could change. You'll get penalized for not writing close. But there is a way to avoid this, which is with open. So the second way to open file, so let me just say this, opening a file, and then with open a file. So the second way you can open a file is using with open, and let's say my stuff.txt bracket, comma, let's say for example W, and then we put this. If we do this, any code we write inside of here, wrong programming language, my bad. Any code that we write inside of here will execute while the file is open. And once you're done with your different things you want to be executed, like code to, then let's say you're done, you want to exit the file. You can just unindent and continue and move about your day, and it will just automatically close the file. So you might be wondering, wait, can't we just use this all the time? Isn't that a great thing we can do? Well, the problem lies in the fact that the examiners kind of want you to still prove that you know what with does. So you absolutely must write a comment here saying using with automatically closes the file. Like, you must state that. If not, they will not give you the marks. They will think you just lucked out, I guess. But yeah, I believe I've lost like 1 or 2 marks that way in one of my J1 exams, and I've just taken that to heart. I've never been more careful to check after that. So just keep that in mind. That is a genuine problem you might face. So beyond that, that's, I guess, opening. Let's kind of go to the next things we can do. Alright, so now let's take a look at reading and writing in a bit more detail. So let's create a file, right? And let's add some information to it and try to read from it. In this case, let's not use the very caveman primitive open to close functions. Let's use with open. You should honestly try to use with open as much as possible so that you don't lose out on marks that are ridiculous to lose out on. So with open, let's do, for example, my work.txt. And since we're creating a file and we would like to write information to it, we put W, right, as, let's say, file. In this case, we do this, and then we file dot write. And in here, let's put hey, and then I am a student. I don't know, I'm not very creative today, but let's just kind of put that out and see what happens. Let's do this. If you notice, again, nothing happens, but if we write very similar code, except for a read version of this, by doing mywork.txt, comma, R as file2 in this case, and we put file.read, file2.read, well, nothing exactly happens. And why is that? Well, even though this is the correct way to read, you're not exactly doing anything with it. File2.read returns something, but there's no way to kind of see what that something is just by doing file2.read. So how do we do this? We create this thing called output is equal to file2.read. We're basically taking whatever value, information, stuff, government secrets is read and putting it inside of output. And with output, we can read whatever's inside to see what we kind of gathered from it. So let's kind of put print output and enter. Whoa, it says, hey, I'm a student. And wait, that's a question mark? I didn't even notice. Okay, whatever. So yeah, now that we have this done, you can kind of see how to read and write at a very basic level. However, this gets a bit more complicated later on when you have new lines and, like, I guess, commas and weird stuff that makes sentences differentiate from each other, I guess. So for now, what we can deal with is this. And one interesting thing you can do with the read function is that you can add a number here, which again changes the number of characters that are read from the file in one shot. This can be useful, but is also not really recommended because usually when you deal with files like this, the input inside of files is not standard, so you might be missing out on information by using this method, I guess, a bit greedily. So don't really try to do that. Yeah, next up, I'm going to cover, I guess, a few more ways you can read and write. So let's take a look at this. So we have lines, right? Which is kind of a list with a bunch of different strings inside. Don't think about the \n's too much. It's just a bunch of strings inside of a list. That simple. How do we write this to our file? Well, let's use a new method. This method is readlines. So how readlines works is you can effectively take all of these different things and write them to the file in one shot, and the \n makes them, well, line by line. So if we run this real quick, let's read this file and see what happens. So with open mywork.txt, actually we have the code kind of above, so let's just use that code. Whoa, it says my name is Slim Shady, and you have to observe two things here. Firstly, here I'm a student has disappeared. It was in the file, it was never deleted, but it has disappeared. Why? Well, if you use write, like I told you, it rewrites all of the contents of the file, which is why it's not as safe as append. So, by writing my name is Slim Shady to the file, you have effectively overwritten, like you've wrote over the here I am a student that already existed on there. So, the contents have kind of been replaced in a sense. That's the first thing you have to look at. The second thing you have to look at is these are stored line by line, and that's because when you put readlines and you put \n at the end of every single one, it creates a new line for every single value. So let's remove the \n and see what happens. If I do this and I run this, it says my name is Slim Shady without the \n, which shows you that readlines just throws everything you throw to it. It just throws it into the file without much care, and the formatting has to be done on, like, it's on you to do the formatting, kinda. So now that we have actual stuff inside of our files, let's look at how we can read in different ways. So let me just revert the changes for this real quick, because I am going to need the \n's real quick. Great. So we have this. Now, how do we read files slightly differently? Well, if you want, we can use this thing called the readline function. Readline effectively reads line by line of the file by, again, going and seeing where the end line is stated. So the end line is your \n basically, and it creates a new line below it. So it just goes line by line on your text file and kind of outputs whatever is in that line by line. So a few things to note. Inside of the brackets over here, whatever value you write inside there is, I believe, the size, which is like the amount of, I guess, bytes that you would like to read. But yeah, it's not characters, so I don't think you need to worry about it too much. And also, you're very rarely going to use readline, in my opinion. You're more likely to actually use readlines, which effectively gives you this. Readlines gives you a list of all of the different values, right? All of the different lines as strings with the \n behind it. And I guess the reason why people don't really like file I/O is because they don't understand how to clean these outputs to make them presentable and like actually manipulable. So let's say instead of this, I had a bunch of values, like my scores for tests, for example. Let's say I put 90, I put like 80. Let me just make this quicker. 100. Don't worry, I'm not that smart. I'm just giving you example numbers. If I were to put my actual scores in there, it would probably be like really disappointing, and you probably wouldn't watch my channel, but it's fine. So yeah, let's just write this, right? And oh wait, I forgot. Let's just put \ns so that it's, I guess, slightly easier for us to show what we're trying to show. So yeah, we have all of our scores in here, and we do this, you get these. Now, what if I asked you to kind of add all of the scores on this file together? Well, that would be really, really, really annoying, because again, you kind of don't exactly know how to add strings with end lines attached to them. So this is where you have to learn, I guess, the art of how to clean your data. So firstly, you have to understand that output is a string. Sorry, it's a list with all of these different things inside. So the first thing we need to do is for value in output, and then you mess with kind of the values themselves. So the value, which is a variable which keeps changing for every single value in output, you mess with that. And again, you can't edit back the same list you're iterating through, so you need to create a new list. In this case, let me just say cleaned data, right? Let me change this to data and this to data. So for value in data, how do we kind of clean it? Firstly, let's kind of remove the \n. So how we can do this is cleaned data dot append, since you're adding to the back, dot append value, because it's a string, except let's kind of see how we can use this to mess with it. So if I do cleaned data to print out the entire list, you get this, because now when you do value, right, and then :-2, it's basically saying remove the last two characters from the clean data. Let's remove it and see what happens. I always recommend printing out the list through every step of manipulation, because it is just kind of easier to see what's going on. You don't have to do everything in one shot and guess whether it works. But you have a problem still, which is the fact that all of your data points, your elements inside of your clean data list, they're all strings. You can't add strings together, so we need to typecast them to integers. We can do that in the exact same line as your append. How? By just adding int over here. By doing this, you have effectively turned every single value. You've basically taken the value, right? For example, 7 \n holding string. You take that, you say remove the \n, now convert it to an integer, and then add it. Do the same for 9, 10, 8, 9, and all as above. Sorry, you might have noticed there's a small problem, which is these are not my actual marks. I just realized. I think you're supposed to do this. Yes, my -2 was wrong. Again, if you just kind of mess with the value, you can see at what point it's too much, at what point it's correct. I guess because \n is counted as a single unprintable character, so it makes sense. But yeah, you don't need to get this perfect. Like, I don't memorize this kind of thing. You just need to keep messing with it and outputting your value until you realize that it's correct. So yeah, this is your thing. You get your clean data.append. Now all you need to do is just sum your cleaned data out of the loop. Whoops, don't do it inside of the loop. Then you get... Actually, you can just print this. I believe. I hope I'm right. Yeah, Python is magical. You get, 443, which I don't know if that's correct, but let me just divide it by, let's say, I don't know if this is going to work, value.count. Yeah, wait, you can't do value.count, never mind. If you try to... Oh, wait, I can do it by data.length. So if I do, for example, len data. Oh, whoops. Forgot a parenthesis. Then yeah, you get 88.6, which should be my average mark. So this is kind of exactly how you can mess with things at a very basic level for cleaning. There is another kind of cleaning I would like to go through called stripping and splitting, which I will do next, I believe. Okay, welcome now to, I guess, the hardest part of File I/O. This is my 5th time recording this, because every time I record this, something goes horrifyingly wrong and I have to restart. But it's okay, let's just get right into it. We have 3 friends, John, Jeff, and Josh. They all committed very different crimes, right? John committed theft, Jeff fought a bouncer for some reason, and Josh loves scamming elderly people. Not really the greatest of people, I guess, but let's kind of find a way to list their charges in a nicer manner. Because right now, right, let's just add this to kind of read the value. And you might notice there's no R over here in the area over here. And that's because if you leave it blank, it'll automatically default to being an R. So let's quickly go and file.read and see what we kind of get. And again, let's print that so that we don't get any, I guess, blanks. So if we do this, whoa, what just happened? Oh, whoops, sorry, it's data.read. Yeah, if you do this, you'll notice something. You get all of the things in one shot, but there is a small problem. Let's go and put a type on this real quick to look at the type of what data.read is. You'll notice that it's a string. Data.read gives you a string. That is not good because if you have a giant string, how do you split it up? Well, you use the split function. You can't just look at like strings with respect to kind of a random thing in the middle if you don't use the split function. What do I mean by that? Well, in the split function, you can choose a character to split the string with. So let me show you that actually in action. Let's look at strip. Sorry, it's not strip, that's for later. Split. If I do split, right? Let me just erase type so that it's easier. If I do split on this, you get John committed theft, etc. because it splits using the space. If you split everything using the space, you get this is your first value, this is your second value, this is your third value, as accurately reflected in the list over here. John, committed, theft, and then the comma, etc. But here's the thing. What if you don't want to split it based on the space? What if you wanted to split it based on, let's say, the comma? Well, you can do that. If you do that, you get John committed theft, and then the comma which breaks it, Jeff fought a bouncer, and the comma that breaks it, and then Josh scammed elderly people. This is kind of the way you're supposed to do it. And you will be using dot split on commas a lot inside of your thing, inside of your entire career. But the problem lies in the fact that there are spaces left over inside. Like you look over here, there's an ugly space over here. I want to get rid of that. That's so ugly. So what exactly do we do? Well, before we proceed, let's just quickly check back on something. If we look at the type of this, it is a list now, because when you take a string dot split, you return a list. So let's store that inside of a thing called cleaned data. Cleaned data is equal to data.read, etc., etc. And if I just do cleaned data at the end, well, what? Oh yeah, I'm missing there's an extra thing. Yeah, if I do this, then you'll see that this is your cleaned data. It is just a list of 3 different strings that are all very kind of messy because of the spaces. And again, this thing where you just kind of put it on its own, it's only for Jupyter Notebook. You can't do this in regular Python. Just keep that in mind. It's not really good practice unless you're testing your code and you want life to be easy. So yeah. Okay, so now that you have that in check, let's see how we can clean stuff up a bit further. Now, what if we iterated through cleaned data? We did for I in cleaned data, right? Which basically refers to this, and then this, and then this, right? For I in cleaned data, we do, let's say we want to create a new list called cleaner data, or cleaned and stripped data. Clean stripped data, that's much easier to understand. So what we can do is cleaned stripped data dot append, right? And you'll be appending I, because I is going to be the string that says John committed theft spacing, Jeff committed bouncer, fought a bouncer spacing, etc. So we do dot strip on this. What's going to happen is you'll get John committed theft without the spacing, same for the other 2 lines, and it'll all be appended to cleaned stripped data. So if we go to cleaned stripped data, run this whole thing, you get this, which is all of your different lines without the pesky annoying spaces in the middle. That is kind of how you can use stripping and splitting. Again, remember, there is no format you have to memorize for stripping and splitting. You just need to understand how it works. And if you're ever confused about the return types that stripping and splitting give you, just remember you can use the type function to check. Always check. The thing that you need to understand once again is that you're not supposed to memorize any of this. I don't memorize. That's why I make so many mistakes in my tutorials. What you need to actually look at is how you can test it on the spot and understand it as you go. That's about it. See you next time. Bye bye.